Today we're going to introduce gases in kinetic molecular theory. So first I want to talk about two concepts that you need to understand in order to understand how gases behave. One is kinetic energy. Kinetic energy is the energy of motion, and it's defined as 1/2 of the mass times the velocity squared for the molecules in a sample. So the faster they're moving and the heavier they are, the more kinetic energy they possess. Now, temperature is also another term you're all familiar with, but to give you the actual definition of it, it's the average kinetic energy of the molecules in a sample. So temperature is directly related to how fast the molecules are moving and the forces they can exert on their surrounding. So here and I want to talk about the different states of matter, solid, liquid, and gas. We're not going to talk about plasma. This is a solid system of oxygen. You can see that the molecules have some kinetic energy because they're moving, they're vibrating in place, but they're not moving and making new neighbors. If I add some kinetic energy and convert this sample into a liquid, you can see that the molecules are free to move and form new partnerships, make new neighbors. They can translocate, and they're also vibrating. If I continue to add kinetic energy and give them enough force to break away from each other, give them enough strength to break away from each other, they become gases. And you can see that gases don't have a fixed, they'll take up the space of whatever container they're in. They don't have a fixed shape like a solid does. Liquids have a fixed volume but not a fixed shape. And now these molecules, the more kinetic energy they have, or the higher the temperature, the harder they're going to be colliding with the walls of the container. So as I add this thermal energy, that's going to get transferred into increasing the speed with which the gas molecules move. So, our first demo for the day is the can collapsing experiment. So right now I have a can filled with a tiny bit of water that's sitting on a hot plate, and the water inside is being converted into steam as kinetic energy is being added to it. Then I'm going to invert it into that ice bath right there, and hopefully this works. As you can see, the can was crushed. But why? I want you to think about that. What caused the can to collapse like that? Right now, I'd like you to fill out on your worksheet what you think. Pause. For our second demonstration of the day, I would like to show you what happens when I apply a vacuum pump to this container with a glove that is sealed, tied into a knot, and taped up to the wall. I'm going to turn it on now, and I want you guys to try and explain why this is happening. As you can see, the glove has clearly expanded. But why did this happen? If you think it inflated, you're wrong, because if it had added air to it, this wouldn't happen when I removed the vacuum. So now we're going to do our third and final demonstration. And what we're going to do is I'm going to have this water, it's just water with some rocks in there, and I'm going to apply the vacuum pump. It's room temperature, and I'm going to show you just straight up magic. Okay, come up here. Come up here. See how the water is now boiling? Here we go. Put your hand on that right now. Boiling water. Touch it. Ah! I'm just kidding. It's not. Is that hot?
No.
No, it's not. You can sit down.
Okay.
You're in the video.
What you can see now. Sorry, Mikhail, that didn't have you somewhere.
It's okay.
The water was boiling, and it's only room temperature. Why would that happen? I don't want answers. This is for the video. This is for you to think about. Come up with your best guess.